In this video, we will learn the internal architecture of our 8255 PPI, that is Programmable Peripheral Interface. So the question can be asked in the exam, draw the architecture of our 8255 processor and explain each and every block in detailed manner. So whenever we have to draw the diagram in the exam, then it's difficult to remember each and every block and how it can be drawn. That question can be comes to our mind. So I will give you some techniques, and whenever you remember that technique, you can easily draw that diagram in the exam. So the first one, you have to remember the data bus and address bus of our 8255 microprocessor. So in that 8255 microprocessor, there are 8 bit of data bus will be available, and that is from D0 to D7. So here we have write this data bus buffer block, and that is used for transferring our data signal over this data bus internal line. The next one is address bus. So in that 8255 architecture, we have two address bus signals are available, and that is A0 and A1. This is also called as the select lines that we have already learned in the pin diagram of our 8255 PPI. So the description for the pin diagram I have given in the description box. So third point is, you have to remember that each and every IC is having the read bar and write bar signal. So read and write signal will be used for reading and writing the data from data bus. So here you can see this RD bar and WR bar. The signals are given in that read write control logic. And these two address bus are there, that is A0 and A1. That signal is also given to our control logic. Then the next point is what you have to draw. The fourth point is you have to draw the reset signal and the chip select signal. So these signals will be there in our read-write control logics. So basically this read-write control logic consists of total 5 signals. The first signal is read bar, then WR bar, that is read and write bar. These are the low signals are there, so that we have to use their NOT gate. Once we are using that NOT gate, that time they are selecting their input for reading and writing the data. These address bus signals are there, address lines are there to select the signal for with the help of chip select signal. If the signal is low, then these address lines will be selected. So how these address lines will be selected, that we have already learned in the previous lecture of pin diagram of our 8255 processor. So here we have the two address lines, that is A0 and A1. So once it is 0 and 0, it is 0 and 1, it will be 1 and 0, and this is 1 and 1. Once the signal will be 0 and 0, that time our port A will be selected. If it is 0 and 1, then port B will be selected. And if it is 1 and 0, then port C will be selected. And if it is 1 and 1, then we are selecting our control registers. So here we are using that A0 and A1 lines, and that are used with that signal, that is chip select bar. So this signal will be 0, that time the signal will be selected, and it is always 0 once we are selecting our port A, port B and port C, as well as our control register. If the signal is 1, then there is no selection of that line for our port address line 0 and address line 1. So whenever we have to draw this diagram, that time you can consider the first point is read-write control logic. And there are total 5 signals that we have to remember. that is RD bar, WR bar, then reset signal, chip select signal, and the address lines will be available. And on the bottom side of that read-write control logic, we have this chip select bar signal will be there, and that is connected with that NOT gate. So here you can consider that the data bus signal will be available for transferring this data signal. So this is the first part. This one will be second part. Now we are done with that address bus, data bus, read-write control logic. Now we have to move with that groups of our 8255 processor. So there are two groups are available in that 8255 architecture. So these two groups will be group A and group B. So check in that diagram. This is our group A and this is our group B. So this group A consists of this port A. So port A consists of total 8 pins. In our 8255 architecture, there are 3 ports, that is port A, port B and port C. Each and every port is having total 8 pins. So 8 into 3, total 24 pins will be available for each and every port. So now here you can consider that this group A consists of our port A, and that is from PA0 to PA7. Group B consists of this port B, and that is included in group B port B. And these pins can be considered as PB0 to PB7. So now we are done with that group A port A and group B port B. So in case of group A, you are writing here port A, and in case of group B, you are writing here port B. So these are the ports are available. Now we are left with our port C. So check in that port C architecture, we are dividing our port C into two parts. So this is our lower part, that is from PC0 to PC3, and this is our upper part, that is PC4 to PC7. So in that architecture, there are two groups, that is our group A and group B. So in that group A, we are adding this upper part of our port C. And in case of group B, we are adding the lower part of port C. So that is the architecture of our 8255 microprocessor. So what you have to remember, first of all, data bus, then address bus, read-write signal, reset signal, chip select signal, and later on this group architecture. So in case of group A and group B, there are two groups are there. In case of group A, you are writing as port A and the port C upper part. And in case of group P, you are writing this port P and the lower part of our port C. So these pins will be considered in our port A, port B, and this one is for port C. So total 24 pins are there and that are included in our group A as well as in our group B. Whenever we are considering this term, that is group A and group B, each and every group is having the 12 pins. So how we can consider these 12 pins? You can see here, this part is considered in our group A. That is port A pins will be considered in our group A. And this port P will be considered in our group P. So how many pins will be covered here? Total 8 pins are already covered from port A and port B respectively. And now in case of group C, we are considering here this port C will be added in our group A and group B. In case of this port C, PC4 to PC7 will be added in our group A. So 4 pins are added in our group A, so it will become 12 pins will be there in our group A. And the lower part of our port C will be included in our group B. So these 4 pins are added in our group B and it will become 12 pins in our group B. So in case of 8255 PPI, you have to remember this point, that is which consists of 3 ports, that is port A, then port B and port C. So each and every port is having total 8 pins, and out of this 3 port we will get 24 pins. We have total 2 groups, that is group A and group B. So each and every group is having total 12 pins. So how we can consider these 12 pins? In our group A, which consists of all pins of our port A, that is PA0 to PA7, and the upper part of our port C, that is PC4 to PC7. And in case of group B, we are considering this port B, PB0 to PB7, and the port C of our lower part, that is PC0 to PC3. So whenever you remember this architecture, then you can easily draw this architecture diagram in the exam.